In this section, we will talk about the system of linear equation in three variables. In section 5.1, we had a system of linear equation with a two variable. Okay. Now here we will try to solve system of linear equation in three variables. Okay. Now, so what's the difference? So if we have a system of linear equation in a two variable, or if we have a linear equation in a two variable, what is the graph of those equation with a two variable? We get a straight line, right? So here in 5.1, so this is one linear equation, right? Straight line, and this is another linear equation, straight line, and we wanted to find a common point, okay, as a part of solving this system of linear equation. Now we have a three variables, okay, and three variables means here we are not talking about line, we are talking about a plane. Now here, so we've been talking about Cartesian coordinate system with a x-axis and y-axis. Okay, so this is our x-axis, this is our y-axis, this is our origin. So we do have a two variable x, y. Now in this section we have a three variable. We have extra axis. Okay, so we have x-axis, we have y-axis, and we have z-axis. Okay, and this is origin. So we are talking about three-dimensional. So two variable means is two-dimensional. Okay, three variable means we are talking about three-dimensional. And can you think of a three-dimensional? Now here, for example, if we take this corner as our origin, so let's take this corner as our origin. So we have this horizontal line, let's call this our x-axis, this is our y-axis, and the vertical one as a z-axis. Okay, so we are trying to solve the equation with a three variables. Okay, now if we have a two variables, then we only have our horizontal axis and vertical axis. Okay, now we have three axes, x-axis, y-axis, and z-axis. Okay, now before we solve this system of linear equation, so let me go here. So here, when we draw a graph of each linear equation with a three variable, we get a plane. Okay, so here we have this plane. So this is one linear equation with a three variable. So we have second plane here, we have third plane here. And if we have all these three planes parallel to each other, there is no solution. Okay, and if three plane, so this is first plane, we have second plane, third plane, and if they intersect at one point, one common point, we have one solution. Okay, now the next situation here is that if we have a three plane and if they intersect in such a way that they make a line. Now just let's take, we have this as our one plane. Okay, this is our second plane. Now if these three plane, let's say so here, so if all these three are connected in a straight line, so if all these are three connected here, how many points do we have? Infinitely many, right? So if three plane, they are connected in a line, so here in a straight line, then we have infinitely many solutions. Okay, if three planes, they are exactly same, we have infinitely many solution. If plane are parallel to each other, there is no solution. Okay, and if two planes are parallel and one is not parallel, or one is intersecting other two plane, then there is also no solution. Okay, so these are the different cases we will see. Now here we have an example. So we have this system of linear equation in three variable. So let's try to solve this. Okay, we will try to find the value of x. Okay, so from this linear equation, what do we know about our g? We already know what is g equals to, right? So g is equals to 2. This is given to us. So we know g is already equals to 2. Now let's try to find x and y. Now we have this second equation, y plus z equals to 0. Now here we already know the value of g, right? So let's substitute g equals to 2. So if we substitute g equals to 2, what do we get as our y? So we subtract 2 on both sides, and our y is equals to -2. Okay. So we have a g equals to 2 is given. Now the next we want to find the value of y. So we substitute value of g in this second equation. Now the next we want to know the value of x, right? We know what is g, we know what is y. Now let's substitute g and y in our first equation, and we will get the value of our x. So first equation is x plus y minus g equals to 10. Now let's replace our y by -2, okay, g by +2. Now we simplify this, x minus 4 equals to 10. We add 4 on both sides. Our x is 10 plus 4, 14. So here our x is 14. Now we rewrite all these values together. So you start from x. So x coordinate is 14, y coordinate is -2, and g coordinate is +2. Okay. And this is a point which is common for all of these three linear equation. So we have one solution for this system of linear equation. So it's very similar to section 5.1. Okay, we have one additional variable. Okay, that's the only differential. Okay, any question on this part? Now, so let's go to the next example. So here we have this system of equation. Okay, so let me call this as a first equation. So let me call second equation, and let me call this is third equation. So our target is finding the value of x, y, and g. Now if we have, so the first one is very easy, okay. Now here this is not easy. Now if we have a system of equation with a 3 variables, now we use the same method, elimination method, okay. We will try to eliminate one variable by adding or subtracting any 2 equation. Now just pick any 2 equation, okay. You can pick equation 1 and 2, you can pick 2 and 3, or you can pick 1 and 3. We add those 2 equations and try to eliminate one variable. Now how can we eliminate one variable by adding any 2 equation here? So which variable is easier to eliminate? Okay, now here, so we have positive 2y in equation 1 and negative 2y in equation 2, right? So if we add equation 1 and 2, we can eliminate y. So let's go ahead and eliminate our variable y by adding equation 1 and 2. So we add equation 1 and 2, okay? So equation 1 is negative 2x plus 2y plus g equals to -6. Equation 2 is x negative 2y positive 2g equals to -1. So we are adding these 2 equations. Now this is 0. So negative 2x positive x, negative x, positive g plus 2g, that is positive 3g equals to -6 plus -1, -7. and let's call this is our equation number 4. Okay, at first you can eliminate any variable. You can, if you want, you can eliminate x, y, or z, but here it's easier to eliminate y. Okay, now the next here, now we added equation 1 and 2, right? Now we take another pair of equation and eliminate exactly same variable y. Now we picked 1 and 2. Now let's pick equation 1, 3 or 2, 3, okay, and eliminate y. Now how can we eliminate y? Okay, by adding any two equation from here. You are not allowed to add 1 and 2. Okay, we already did. Now we have the option 1 and 3 or 2 and 3. So these are the options we have. Now we have to eliminate same variable that you eliminated at first. So we eliminated y. Now how can we eliminate y from the remaining pair of equation? 2 and 3. Okay, so do we add or subtract? So here in equation 2 we have negative 2y, in equation 3 we have positive 2y. So if we add, we get y equals to 0. Y is eliminated. So let's go ahead and add equation 2 and 3. So second time you have to eliminate same variable, okay? So let's add our equation 2 and 3. So our equation 2 is x minus 2y plus 2g equals to negative 1. Equation 3 is 3x plus 2y minus g equals to positive 3. We are adding these two equations. So y, this is 0, x plus 3x, 4x, 2g minus g, that is positive g equals to negative 1 plus 3, positive 2. And let's call this is equation 5. We had a 3 equation, okay? We eliminated our variable y by adding 1 and 2. And in the second case, we eliminate same variable by adding remaining pair of equation. Okay, any question up to here? Our target is finding the value of x and z. Now, if we look at equation 4 and 5, what we see? We have a 2 variable, right? So in equation 4, we have xg. In equation 5, we have xg. Now, let's eliminate one variable by adding equation 4 and 5. So let me write 4 and 5 together. So we have equation 4, negative x plus 3g equals to negative 7. And our equation 5 is 4x plus g equals to 2. Now we are back to our section 5.1 where we had 2 variables. Now what variables do you want to eliminate here? So we have x, g. Okay, if you want to eliminate x, now we have 4x here. Now to eliminate x, we need to have negative 4x here. Now how do we get negative 4x here? Multiply by 4. So let's multiply equation 4 by 4. Okay, so you multiply this equation by 4. After that, we get 4 times negative x, negative 4x, 4 times plus 3g, that's 12g, 4 times negative 7, that is negative 28. Okay, so we are adding with our equation 5, so this is gone. So we have g plus 12g, that is 13g equals to negative 26. Now we divide both sides by 13 and our g is equals to negative 2. So we know what is g equals to. We still have x and y to find. Now how can we find the value of x? We know g is equals to negative 2. Now how do we find the value of x and y? So to find the value of x, we substitute g equals to negative 2 in our equation 4 or 5. Okay, you can substitute g equals to negative 2 in equation 4 or 5. We always get same answer. Okay, so let's take equation 4. So let me use equation 4, but you can use equation 5, okay? So 3g equals to negative 7. Now you substitute g equals to negative 2. So we have negative x plus 3 times our g is negative 2 equals to negative 7. So negative x, 3 times negative 2, negative 6 equals to negative 7. You add 6 on a both side. Negative x equals to negative 1. Divide both sides by negative 1. And our x is equals to positive 1. So we know g. We know the value of x. Now we only need the value of y. Now how do we get the value of y? Where do we have variable y? In equation 1, 2, 3, right? Now we go back to our equation 1, 2, 3, and we substitute x equals to 1, g equals to negative 2. And you can pick any equation, okay? You can pick 1, 2, or 3, does not matter. We get the same answer. So let me pick equation 2, but you can pick any. So x minus 2y plus 2g equals to negative 1. Now we replace our x by positive 1. We don't know what is y. We replace our g by negative 2 equals to negative 1. So we have 1 minus 2y, positive 2 times negative 2, negative 4 equals to negative 1. So 1, negative 4, that is negative 3 minus 2y equals to negative 1. We add 3 on both sides. So we have negative 2y, this is 0 equals to positive 2. We divide both sides by negative 2 and y is equals to negative 1. We know x, y, g. Now let's write all this together. So you write down x coordinate first, write down y coordinate second, and g coordinate third, and inside the parenthesis. And this is the solution. This is the 1 point in the 3-dimensional, okay? And this is the solution for this system of linear equation. Okay, any question up to here? Now before we start number 3, let's go to number 4, okay? So here we have 3 equation. We do have a 3 variable. So let's call this is our equation 1, this is our equation 2, and this is our equation 3. Okay, now let's try to eliminate one variable. Now at first you can eliminate any variable. Now which variable is easier to eliminate? Okay, y. Okay, so we have y in equation 2 and 3. We have positive y here, we have positive y here. If we add, we get 2y. Now to eliminate y, what we need here? Negative, right? And how do we get negative here? We multiply both sides by negative 1. So let's multiply our equation 2 by negative 1. So we have equation 2, 3x plus y plus 2g equals to 0. And we are multiplying this equation by negative 1. So we have negative 3x, negative y, negative 2g equals to 0. And adding this equation with equation 3. So our equation 3 is 4x plus y plus 3g equals to 5. So let's add. Now y is gone. So we have negative 3x, positive 4x, that is x, negative 2g plus 3g, that is g equals to 5. So this, let's call this is our equation 4. So we multiplied our equation 2 by negative 1 and then we added with our equation 3. Now, so if we, okay, now let me write that equation 1. So our equation 1 is x plus g equals to 3. So this is our equation 1. Now both of these equations has the same variable x, g, g. Now let's eliminate one variable from these two equations. So which variable do you want to eliminate? Let's eliminate x, and if we want to eliminate x, we need to have negative here. So to make negative, we multiply both sides by negative 1. So let's multiply our equation 4 by negative 1. So if we multiply equation 4 by negative 1, we get negative x, negative z equals to negative 5. And we are adding this with equation 1. So this is 0, this is 0. So we have 0 equals to negative 2. Now what does it mean? Is it true statement? No. It's false. Now from here, what is the conclusion? There is no solution. Okay, this system has no solution. No solution. If you get same number on both sides, it's infinitely many solutions. If you have two different number and they are equals to each other, then it's no solution. 0 is not equals to negative 2. So from here we can conclude that this system has no solution. It means they do not intersect. Okay, all of these three planes, they do not intersect at a common point. Okay, any question? Now let's go back to our example 3. Okay, here we have two equations. Okay, so we have two planes and we want to find the solution for this system of linear equation. Now which variable is easier to eliminate here? So this is 1, this is 2. So which variable do you want to eliminate? It's easier to eliminate y, right? One is positive, other is negative. So let's add these two equations. So if we add these two equations, we get negative 5x, negative 3x plus 5x, that is positive 2x. This is 0. Then positive 2g equals to 0, right? Now we don't have, okay, now this we only have the two equations, and we have two equations and our variable is 3. So to solve that, okay, so if you have three variables, and in order to solve that equation, we always need at least 3 equations. Okay, so we only have 2 equations, means we cannot find the solution here, or we can simply say no solution. Okay, so if you have 2 variables, we need at least 2 equations to solve. If we need 3 variables, so if we have 3 variables, then we need at least 3 equations to solve. Okay, now here we are only given with a 2 equation here, so there is nothing we can do here. Okay, so for this case we cannot find solution, or just simply write down no solution. Okay, now let's go ahead and do some examples. Has anyone carried book? Do you have book? Has anyone? Okay, so let's go ahead and practice a few more. Okay,